Okay, so just finishing up the last homework question, which was number 3 on page 459. Cos of 60 is 0.5, so this will be 30 kilometers east. And 0.866, this will be 51.96 kilometers, and that'll be north. And it says something in the question like they only can go at 2 kilometer intervals or something, so it'll be right on the intersection in one, and these guys will have to walk 40 meters to get to in the y direction. Okay, so there's your homework. So now what we were doing in class on Thursday were the 4 cases of vector addition, and we were almost finished. We were on case 4, and case 4 was any other angle, and there are 2 ways of doing it when it's any other angle, and I don't know that I'll remember what forces I was using in today's class. So let's say we had 40 newtons going this way, and it might have been 50, but I'm not 100% sure. 50 newtons going this way, and we could make our angle here 36.87 degrees. So one way to solve this is to take my 50 Newton angle and move it over so it's head to tail with my 40. So here it is. And then and in here is 36.87. And then remember from last year we said always the resultant starts where the first one started, ends where the last one ends. And this 50 Newton angle, or 50 Newton vector, is really a hypotenuse looking for its legs. And so we can find x and y here because we have the hypotenuse and we have the angle. So x is just going to be the adjacent side. So cos of 36.87 will equal x over 50 newtons. So x will equal 50 newtons times the cos of 36.87. And I believe that should be 40, but I'm going to double check it because you're not here to keep me honest. It is. So x will be 40 newtons. And y is the opposite side, so it'll be sine of 36.87 is equal to y over 50 newtons. So y will equal 50 newtons times the sine of 36.87. That should be 0.6, so y should be 30 newtons. So this is 30 newtons here, and this is 40 newtons here. So if that's true, remember once you find the legs, the hypotenuse disappears. So now we have our 40 newtons here, and we have a second set, 40 newtons here. We have our 30 newtons going up like this, and my resultant will be here. And so now it looks like case 3, it's a right angle triangle, and I can just do the Pythagorean theorem. So r squared is going to equal 80 newtons squared plus 30 newtons squared. Take the square root. So 80 newtons squared is just 6,400. 30 squared is 900. Take the square root. R should be equal to 85.44 newtons, but then you also need to find the angle. And it would be inverse tan of 30 divided by 80. And when you do inverse tan of 30 divided by 80, you get 20.556 degrees. Which way are we measuring off of? That was east. Which way did we turn? That was north. So one way to find this answer is to break it into its components like you were doing last night for homework. And then once you have it in those components, add up all the x's, add up all the y's, do Pythagorean theorem. Going back to the original question, the second way, 40 newtons here, 50 newtons here, the angle in here was 36.87 degrees. This is still my resultant. The second way that you can do now that we didn't do in grade 11 because you didn't really learn it to second semester math is you could use sine law and cosine law, because you have two sides, and if you know this is 36.87, then inside here must be 143.13. So you have two sides and an included angle. Of course, to use the sine law and the cosine law, one would need to remember them. Sine law is either sine A over A equals sine B over B, or you could write it as A over sine A is equal to B over sine B. Which way what you put on top for me usually depends on what I'm solving for. If I'm solving for a side, I put the A on top. If I'm solving for the angle, I put the sine A on top. So that's the sine law. It's the easy one to remember. The one that people usually have a harder time remembering is the cosine law. Cosine law is c squared is equal to a squared plus b squared. That should sound familiar. Cosine law starts off with Pythagorean Theorem, but it's not quite a right angle triangle. It's missing this section, so it can't just be a squared plus b squared. It's missing a section, so you have to take away something. What are you taking away? Well, you have two sides, so 2ab for the two sides, and it is the cosine law, so you should probably put a cosine in there, and it's always the angle opposite the side you're looking for. Okay, so if you think of it as Pythagorean Theorem minus the two sides you have and the cosine of the angle. Now, how do you know when to use which one? It depends on what you're given. To use the sine law, you need a side and its opposite angle, and then either another side or angle. So here we have the side 40 newtons, but we don't know its opposite angle. We have a side 50 newtons, we don't know its opposite angle. We have an angle, but we don't know its opposite side. We cannot use the sine law here. To use this cosine law, you need two sides and the included angle. So in this particular example, we would have to use the cosine law. So it would be c squared, or r squared, is equal to 40 newtons squared plus 50 newtons squared minus 2 times 40 newtons times 50 newtons times the cos of 143.13. Okay? And then don't forget you're going to take the square root. And when you do all that, my money's going to be on that you're going to get 85.44 newtons. That will be the length of this side. Okay? But we also need the angle. So if we get this to be 85.44 newtons, and now I want the angle, now I have an angle and its opposite side. I have a side and I want my opposite angle. So now I can use the sine law. And so I think I have room. It'll be sine theta over its opposite side, 50 newtons, will equal the sine of 143.13 over its opposite side, which is the 85.44 newtons we just found. Okay, so cross multiply, bring the 50 up. Sine theta will equal 50 newtons sine of 143.13 over 85.44 newtons. Take the inverse sine, and you should get 20.556 degrees. And so you put that together with your C you found up here, it'll be 85.44 newtons, square bracket. Which way were you going first? East. 20.556 degrees. Which way did you turn? North. And you're done. It might just be a coincidence, but check it out. They're the same. So really, it doesn't matter which way you do it in a particular example like this. But the homework questions over the weekend, it's going to matter.